Hello, everyone. Welcome back. It is my extreme pleasure to be able to introduce our keynote speaker. Dr. Sarah Brownell is an associate professor in the School of Life Sciences at Arizona State University. Trained as a neuroscientist, she transitioned to becoming a discipline-based education researcher and now studies how we can make undergraduate biology learning environments more inclusive. She is a co-PI of the NSF-funded CureNet 2.0 Collaborative, which is a group of individuals who are interested in developing and assessing course-based undergraduate research experiences. And we will put that link in the chat. She has experience developing, teaching, and assessing cures in basic science research and science education research. Sarah has received multiple teaching awards and is the proud recipient of the 2020 LGBTQ+ Educator of the Year Award. We are so excited to welcome Sarah. Thank you so much for being here.
Yeah, thank you so much, Pam, for inviting me to come and speak. I wish we were all in person, but I'm really excited about doing this in this virtual format. So I will go ahead and take questions at the very end. My plan is that I'll basically talk for about an hour and then we'll have ample time for questions. But I know that if you're like me, I often think of a question as someone's presenting and then I forget it by the time they get to the end. So please feel free to add your questions as they pop up in your mind. So that said, I will go ahead and start to play my slideshow. Pam, please yell at me if you're not seeing it correctly. So again, thank you all. Okay, that's great. So thank you all for being here. So my goal basically today, I've been listening in this morning to the sessions and it's been really fun to hear about the iCures and the specific cures that Dr. Ken Sweat has been developing. And my goal for this next hour and a half is basically to provide a slightly larger perspective on thinking about developing course-based undergraduate research experiences, some of the benefits of that, and some of the challenges as you're potentially thinking about developing your own cure. And I think, echoing what was said earlier, there's no one right way to develop a cure. And there's actually a lot that we don't know about the impact of cures on students. And so we're really in this space of experimentation, not just for the students, but also for ourselves when we're developing these cures. So the three things that I'd like to talk about today is really position why we should transition our lab courses to integrate research. How should we assess courses that integrate teaching and research? And then give you an example of a study that we've done where we actually backward designed a cure to look at some specific elements of cure and their impacts on students. So the first point, so why should we teach cures, right? And I know that the earlier sessions today highlighted a lot of really positive benefits that could be given to students through these, but I want to position this in kind of a set of larger recommendations. So national recommendations over the past 10 years or so have broadly promoted the importance of getting undergraduates to engage in research. So the Engage to Excel report that came out during Obama's era basically said that every single STEM major that graduates should have some kind of real research experience that they're doing. A lot of these recommendations have been specific to science, particularly biology, but people are advocating for all undergraduates to participate in research regardless of the discipline. Participating in undergraduate research can be really impactful on students. It's a really lucrative activity for students. It can increase a student's odds of persisting in biology, a study has shown, obtaining bachelor's degrees, going on and being interested in pursuing a PhD, pursuing a STEM graduate degree, and actually entering. So if we think about that pipeline, and I know that that's not a great analogy for where a lot of our students are going, but if we think about who gets to grow up and become a practicing scientist or a PhD level scientist, that first level of participating in undergraduate research can become really important. Increasingly, undergraduate research is becoming a prerequisite for science graduate programs, particularly the very best and most elite science graduate programs. So if a student doesn't have undergraduate research, they're going to be at a disadvantage. Now, traditionally and historically, students engage in undergraduate research in faculty research labs, right? But there are a number of problems with this model. So despite faculty being really altruistic and wanting to get as many students in their labs as possible, there's just a limited number of positions available in faculty members' research labs. And at most institutions, including Arizona State University, there's way more students enrolled in our undergraduate biology degree program than positions available. And so, unless institutions can drastically increase the number of faculty, but we know because of budget restrictions we can't do that, we're not going to be able to give every student that experience of working in a one-on-one relationship with faculty members. Further, there's other problems with this model. There's a selection process for who gets to participate because there are often so many students who are interested in undergraduate research and only a limited number of positions available, then faculty choose who gets to come in, right? And they often choose who gets to come in based on who got an A in their course, right? Who they might have interacted with in office hours as part of their course, maybe a student that has previous research experience, but there's some kind of selection process for getting in, and faculty are choosing kind of who's a better candidate. There's in every situation here, students have to know the unwritten rules of undergraduate research. They have to know that they need to approach faculty. They need to know what to include in an email to faculty. They need to know how to advertise themselves or sell themselves to be the best possible undergraduate researcher. In the context of science, the unwritten rules, a lot of faculty don't actually want a pre-med student in their lab because they think that pre-med student is just going to check off a box of doing research. And so students who know the unwritten rules of undergraduate research would know that maybe you should highlight that you're really excited about research and you may want to go on to an MD PhD program. Students also need the confidence to apply and the time to add research onto their normal coursework. And we know that particularly for students who are from lower income backgrounds that have to work, many students are not actually getting paid to do undergraduate research. Most of the time, undergraduate research, you're either getting coursework credit for it or you're potentially volunteering. Obviously, if we could pay students, that would be great. But basically, students with a confined schedule, they may not actually have the time to add research onto the normal coursework. Further, faculty select which students they want, and they are absolutely incentivized to take the best students, however they define them. As I alluded to earlier, top grades in your course, students that they themselves click with, which is a problem because we know that the majority of faculty are white from kind of middle class to upper class backgrounds. And so they may be incentivized to take students that look and feel like them, as opposed to students who actually really could help diversify who gets to become a scientist. And we also know that faculty, like everyone, hold implicit biases that advantage certain populations of students. So studies have shown that faculty are more likely to respond to emails from white-sounding names compared to black-sounding names. Now a pretty famous study from a number of years ago now basically asked faculty to evaluate 2 applications from students, either a male student or a female student. All aspects of the applications were identical except for the name that was kind of clearly a woman or a man, and faculty were more likely to hire the man, pay them more, and that they were going to actually say that they were going to mentor them more. So these implicit biases are going to potentially advantage certain populations of students, which obviously isn't fair. So there's problems with this traditional model of engaging students in undergraduate research in faculty research labs. Only a subset of students can participate, and those students often tend to be from more privileged backgrounds for all the reasons that I just laid out. Now, vast majority of individuals and programs, National Science Foundation, Howard Hughes Medical Institute, historically, their solution to this was to create initiatives and incentives to try to diversify who does research in faculty labs, right? Can we give a pocket of money to a group of students to be able to set up a new program? And I know that that Pam at ASU West is involved in an STEM that's trying to do something similar to this, right? To get kind of different students in research labs. But there's a problem with even this model, right? That even though maybe we can help diversify who gets to get into those research labs, we still can't change the fact that there's only a limited number of positions available and only a subset of students can actually participate. So our solution thereby then is a different solution is to actually integrate research into the undergraduate lab courses, into the normal curriculum, so that then actually we can give that experience to all students, and potentially the students who participate can be from broader backgrounds. So when I say integrating research into undergraduate lab courses, we're thinking about course-based undergraduate research experiences or cures. So there's been if you go into the literature, there's a number of different terms that are used to describe these types of experiences. Some people call them course-based research experiences or CRE. Some people call them research-based courses or discovery-based courses. But in essence, these are all talking about the same thing. And so a number of years ago, Geeta Bangara and I basically put forth this argument that cures can make scientific research more inclusive, that if you develop a bunch of high enrollment cures or many low enrollment cures, it can increase the number of research opportunities available, increasing access. And that if you require students to enroll in a cure as part of their normal curriculum, students don't need to know the unwritten rules of research, faculty don't need to select students, and so that removes the barriers to participation. So really excitingly, cures can offer this opportunity to increase the number of students who participate in research and be potentially a way for every single undergraduate to have a research experience, which is a really cool idea. So when I say a cure or a course-based undergraduate research experience, what exactly do I mean? I know that those of you who joined earlier heard a lot of really good ideas from the iCures that have been developed and how a cure might actually take form. Now, cures are really diverse. If you think about any faculty member on your campus, or even any faculty member in an undergraduate or graduate program that you were participating in, essentially the diversity of research opportunities that are available, that could also represent the diversity of cures that are available. Now, a group of experts on cures and undergraduate research experiences a few years ago came together and thought hard about what makes a cure an actual cure. What are the critical elements of a course-based undergraduate research experience? And they came up with these 5 things. That in a cure, students engage in scientific practices, that they do what scientists do. And this includes everything from thinking about designing experiments, to analyzing data, to communicating their results, to actually conducting the experiments themselves. They said, well, science is collaborative, right? So science can be done independently, but more often than not, science is done collaboratively. And we've seen this kind of giant shift in the way science is done really over the last couple of decades. And so a part of a cure is actually getting students to collaborate and work with each other. Iteration, this idea that you can't just do an experiment once. So Dr. Sweat talked about this earlier. You can't just do one experiment and that's it. You have to typically, you think of it, you have to at a minimum do kind of 3 iterations of something to be able to make a claim. But even more than that, if you think about science, science itself is iterative, right? The reason we have students read prior literature is because we are building on what has been done earlier. So there's an iteration that's implicit in this, in that you're building on what has been done in the past. And then students should know that what they do, someone else will build upon that. And yet you can't just do something once and be done and have a result. And then they talked about that the components of a cure that make it kind of real research are discovery, that what the students are working on are novel, are new, no one knows the answer to it. It's not that the students don't know the answer, but the instructor does. The instructor doesn't know the answer. The broader scientific community doesn't even know the answer. And that there's some kind of broader impact or relevance, that someone cares about those discoveries, that could potentially impact someone's behavior, that someone could take those discoveries and build onto it, right? That it has relevance beyond just the course itself. And so these 5 elements are really useful to begin to think about how cures actually differentiate from other types of lab courses. So if we think about a typical cookbook lab course, so cookbook called that because it's similar to a recipe in a cookbook. Students follow a series of steps to get the right answer. If they don't get the right answer, if they don't cook it properly, then it's messed up. Most of these traditional cookbook lab courses, they focus almost exclusively on scientific practices and often pretty low-level scientific practices. So often it's, can you follow a series of steps? Can you, pipette something? Can you do this particular assay? And if you've done that and you get the right answer, then you write it up and you're good. If you don't get the right answer, then you still write up why you didn't get it the right answer, and you're still usually pretty good, right? The majority of these courses don't have very much collaboration. If any, the collaboration tends to be inauthentic. There's not enough beakers to go around, so you have students pair up and they share a beaker. There's usually no iteration in these courses. Students often come in and every week they do something different. Often this is because it's paralleling what's happening in the lecture class, if this lab is associated with a lecture class, but there's really no building on the past. There's no discovery. They're really trying to get a confirmation experiment. They're trying to confirm what is already known, and no one cares, right? The students don't usually care about this. The instructor usually struggles to care about this. And so there's really no broader impact or relevance. So this is in contrast to what I like to think of as inquiry-based activities. So the term inquiry can mean lots of different things. But when I say inquiry-based activities, I'm talking about those experiences that tend to be kind of, it could be 1 to 3 week experiences where students are working on something that's novel. And that, so by definition, inquiry has to have that discovery element, that what the students are working on is new, it's novel, they don't know the answer, the instructor may not know the answer, and that these can be really powerful experiences for them to begin to think about experimentation and begin to come up with their own hypotheses. Kind of your classic inquiry experiment is, let's test the bottom of our shoes to see what bacteria is on there, or which doorknob might have the most bacteria. And you swab a bunch of doorknobs, you plate it out, and you see, what exists or not. And the students can make predictions on that and see what's new. But the reality is they're not going to build on that. No one's going to publish that, right? It can be a really useful experience for the students, but it's not something where someone's going to take that information and do something with it, right? Inquiry experiences, they're often involving students in more higher level scientific practices, often more on the level of designing experiments and analyzing data. There's often a little bit of collaboration, a little bit of iteration, but the real difference there between cures is that there's no broader impact or relevance. And so when we think about what makes cures really distinct from other types of lab courses, it's this combination between discovery and broader impact and relevance. And in fact, people, including myself, have argued that these are not two separate things. These are actually one thing. That actually what we're thinking on a cure is that the students are working on novel findings that have a potential for an impact. You can't really have one without the other to be a cure. And so we're starting to advocate that absolutely what's necessary in a cure, while all of these are often common aspects of a cure, what's absolutely necessary is that what the students are working on are novel discoveries, novel findings that have broader relevance. And when we use the term real research or authentic research, when we think about the type of scholarship that faculty members are doing, this is really what is absolutely necessary. The other things can add to the experience, and I'll talk more about how we don't really know necessarily the impact of some of these other things, but this is what it's absolutely got to be in the kind of magic sauce of the cure to make it a cure. Now, how do we actually know that cures are going to have an impact beyond the course? Well, the most conservative way of thinking through this is, can it result in a publication? And one of the folks earlier talked about how students in their course actually put together their results in a student publication, and that's awesome. Some people have actually used the student data collected in the course and not even just resulted in a student publication, but actually a peer-reviewed scientific publication, sometimes with students as co-authors, sometimes with students as acknowledged. It depends on their intellectual contribution. But for sure, if what the students are working on in the course ends up in a peer-reviewed scientific journal that someone can read and then build upon, it absolutely is having impact beyond the course. But we know that there's a whole lot of steps that have to happen to go from an initial discovery to actually that publication, right? And so I don't mean to assume that every cure has to lead to a publication. There are some things that you can potentially do, and I'm happy to chat about this further in the Q&A, to maybe increase the probability that you'll have publication quality data, thinking about checks and balances with students' accuracy of their data. But you can absolutely develop a cure that doesn't necessarily lead to a publication, right? Students can work on something and it completely fails. It still can be a cure, even if it doesn't actually result in a publication. And there's often more intermediate time points that you might want to think about in terms of getting the students' data in a way that someone can build upon it, or someone can use it and think about it, that's not actually as formal or as hard as getting a publication. So some cures have been set up where students might add something to a database that other scientists can actually look at, build upon, etc. Depending on your cure, maybe what's most appropriate is not a peer-reviewed scientific paper, but actually something more like a community report, right? Like you're interested in water quality in a local stream or a local place that people swim. And so you have students go in, you collect samples, you have them assess something about the water quality. And actually maybe what you want is some kind of report that you put up at the lake that gives people some indication information as far as whether they should swim there or not, right? And you can envision this, especially for students, this can be something, maybe they're doing something in their dorms and then they can actually have a flyer that gets put out, right? And so again, it's novel, it has a potential for an impact, it has potential for someone someone's behavior to change and someone to actually take up that information and make it more real, right? And more potentially impactful, right? So is it a cure? What matters is that someone outside the course could care or would care about the results. And I really want to be clear here, it's the potential for someone to build on the findings. It doesn't, right? We all have done experiments in our research that fail. That doesn't mean we're not doing real research, right? We're aiming towards something that could be impactful, right? But there's often a lot of steps along the way. And at least when I've taught cures in basic science and in science education, and I've worked with lots of faculty who have developed cures in both science education and basic science, I tell people, assume the first time you teach a cure that it will not work. A million things are going to go wrong and you learn from that, but that doesn't mean that students' experience in the cure isn't a cure to begin with, right? If the intention is there, then it still is a cure, and then you'll learn, right? And you'll tweak things and you'll make it better. So you might be thinking, why am I obsessing about kind of a strict definition of cures? And one of the things that I've really advocated for as far as cures is if we claim that cures can be a way to increase the number of students who are engaging in real research and essentially be a substitute for research in faculty labs, then we have to be conducting real research in a cure. And that's where I think the definition becomes really important. I want to highlight that there's no literature at all that exists that shows that cures are better than inquiry experiences in terms of the benefits to students. Inquiry experiences can be hugely impactful for students. Cures can be hugely impactful. And I'll talk a little bit more about different pedagogical goals and where cures and inquiry experiences might actually be better in a little bit. But if we are taking the equity claim that cures can actually substitute for research, then that's where I argue that cures actually have to include research, and that becomes important. And we often have the assumption that students working with faculty members one-on-one is the gold standard. It's the best case scenario, and cures are kind of a gateway to get into those experiences, or cures approximate that, or cures are not as good as that. But there's also absolutely no data that shows that students' experiences an independent research experience working with a faculty member is better than a cure. And I think that this is something really important that we as a community, as a scientific community, as a scholarly community, need to think about, because I think right now we're making the assumption that those independent research experiences are the best case scenario, but actually students in a cure, because of the additional structure in a cure, because of the additional pedagogical goals in a cure, they may actually be getting far more out of those experiences than some independent research experiences. I like to think about it as you're probably never going to mimic that best case scenario in a research experience where you have the student that super clicks with the mentor, that you have a really supportive mentor, that the project is absolutely what the student wants to work on, right? That you're not going to probably get in a cure. But I would argue also that cures are going to be far better than a lot of independent research experiences where you sometimes have a faculty member even forgetting that a student is in their lab, right? Especially if they're working with grad students and postdocs who are the primary mentors for students. So I think that that's, again, why this strict definition matters. Okay, so I'm going to transition into part 2 now, to thinking about how should we actually assess courses that integrate research and teaching. And again, I want to welcome you. I can't see the chat right now, but please put in your comments or questions in the chat and we'll try to address them as we move forward. So if we're developing cures, if I've tried to convince you that cures are a good thing to develop, and since you've chosen to come to this workshop, you've probably already drank the Kool-Aid a little bit in terms of thinking that cures are good. So how do we actually think about assessing these types of courses? Now, if we look at how we're currently assessing these courses, what we currently do is we get an idea to teach a cure. We plan out the student's research experience, right? What are they going to do? Let's sit down, let's write the syllabus, let's sit down and think about, okay, week 1, they're going to do this. Week 2, they're going to do this. Week 3, they're going to do this, right? And in some ways, what was presented earlier is a little bit of this, right? Having a guideline for exactly what students are going to work on and a template, that can be really great to think about. Here's these broad range of activities that we want students to do. And then when cure assessment folks have come in, they've been like, okay, we want to actually look at the impact of cures on students. How do we actually show that cures have had an impact on students? Well, let's go ahead and actually assess possible student outcomes. And the way they've mostly done this, and myself included, is we've given students surveys of a bunch of different possible outcomes. Some of these outcomes are known outcomes that derive from undergraduate research experiences and faculty labs. Some of these outcomes are kind of known outcomes from inquiry experiences, but we basically give students a bunch of surveys, and then we see what pops out as far as what's being significant, right? We identify cure outcomes from basically giving them this combination of a bunch of different possible outcomes. And this has been the way that we have actually shown that cures mimic many of the same outcomes as undergraduate research experiences, that students can show gains in their ability to analyze data, that they can show gains in their persistence of science or their intended persistence in science, that their project ownership, their science identity, etc. Now, while this, I think, is a really good way to start going about thinking about cures, and it was really important in kind of the initial set of research when we were trying to advocate that cures are this good thing that people should start to develop, it's established an important foundation for the possible outcomes of cures. But what's problematic about this is we've essentially thrown everything, including the kitchen sink, at students in a cure, and then we see these outcomes come out, but we have no idea what is actually in the cure leading to a specific outcome, because we're having students do so many things. We're having them collaborate. We're having them potentially go out in the field. We're having them do a bunch of different types of experiments. We're having them do maybe post-labs. We're having them do pre-labs, right? We're just doing so many different things, and we're not necessarily linking what the students are doing to the outcomes. So I've started advocating with folks that we need to actually turn this on its head. That instead of starting with planning out student research experiences, we've got to start with what we want students to accomplish at the very beginning. We need to first identify cure outcomes, then think about how we're going to assess those outcomes, and then start to plan out student research experiences, right? So thinking about that kind of guideline, you could think about planning out research experiences, but what you have to do before you do that is start off really thinking about what the goal of your cure is. And I think that that's actually really important in some of the comments that I saw earlier is, you know, if your cure, you're putting it into an existing course where students have to learn how to do gram staining of a particular bacterium or something, then you know that that's an outcome that you need, right? But what are additional outcomes that you would want students to achieve in the cure? And then you would make sure that the cure that you're designing actually meets all of your intended outcomes. And this can be dependent on you as the instructor. Maybe you have autonomy over the course completely. Maybe it's you have to actually talk with larger groups of people in your department about what is the role of an introductory chemistry course or an introductory biology course, etc. So this isn't a new design by any means. A lot of you are probably familiar with this idea of backward design. This has been an approach advocated for in a lot of college courses, that we want to first identify with what you want students to be able to know and do. That we have to identify course goals, then think about assessment, then think about the research and learning activities of the course. But when we advocated for it, it was actually the first time that people had actually talked about how you would actually do this in the context of a cure. And cures are a little bit different than typical courses because of that research component. So I want to draw your attention to this particular paper that I wrote with colleagues Caitlin Cooper and Paula Sonerall. So we advocated for the first time that we've really got to use a backward design approach in planning cures. And the reason we've got to do this is that we have two potentially competing demands on students. We have pedagogical goals, teaching goals, what we want the students to actually accomplish, and then we also have research goals, because this is a research course, right? Because this is an experience where we want students to engage in authentic research. So when we're thinking about identifying goals, we've got to actually break down in the cure, what are your pedagogical goals? What do you want students to know and be able to do? And really importantly, by choosing to teach a cure, you as the instructor have already defined the overarching learning goal for students, that you want to provide them with that experience of conducting scientific research. I think that this is something really important to think through, because this may limit some of the other goals that you can achieve, right? But essentially, by choosing to teach a cure, you've decided to do that. And so I want to encourage you to really think through your goals for the course, especially if you're in the phase of thinking about teaching a cure, because maybe what you actually want to teach is not a cure. Maybe you want to teach an inquiry course, and that's totally okay. That's totally great. We have no data that suggests that cures are better than inquiry experiences. But if you want to use cures as a way to replicate research experiences to broaden students, right? Then by choosing to teach a cure, you're choosing to provide them with that experience of conducting scientific research first and foremost. And then in addition to all the pedagogical goals you want students to accomplish, because you're saying that this is a real research experience, you've got to think about what are your scientific discovery milestones, right? Or if you're not in a scientific discipline, what are your kind of academic discovery milestones, right? Or what are your scholarly milestones that are true of your particular discipline that you would want students to be able to achieve? Maybe in a single semester, maybe over multiple semesters, right? We know that research often can take a long time, so you don't have to necessarily think about this on the span of just an individual course, but you as the instructor need to be thinking about how does this research project look for the next, 1 to 3 years. So again, breaking this down a little bit further, pedagogical goals, you're engaging students in research as your first and foremost goal, but then the other goals that you might want to layer on. Maybe you want to teach them some kind of technical skills, right? Maybe depending on your student population, it is super important for them to know how to do X, whatever X technical skill is. So you want to make sure to embed that into your course. Maybe you want to teach them conceptual knowledge, right? Around whatever your topic is, right? So if you're teaching a biology cure, maybe you want to teach them what PCR is, and you want to make sure that they actually understand the concepts behind that if you're asking them to do that as a technique. Maybe you need to teach them what research is. So work that I've done, interviews with first year undergraduate students at ASU, at Arizona State University, we found that a bunch of students don't even know what research is, right? They have complete misconceptions. They think that research is going to the library and just like looking up a paper. They don't realize that research has to involve that kind of novel discovery element of it. Some people have misconceptions that, you have to be wearing a lab coat to do research. Again, there's so much of research that happens when we're just on our computers, right? Analyzing data. So getting a better sense for what exactly research is, that might be a goal for your course. Process skills, maybe you want them to learn how to analyze data, communicate results, et cetera. And then maybe you're interested in psychosocial gains, right? And maybe you're interested in really like lighting that spark in students, getting them really interested in science, increasing their sense of belonging, increasing their self-efficacy, all of these types of things. And then in addition, you would want to sit down and be like, okay, what are my research goals? What is the scientific research question that I'm interested in? Knowing what has been done on that topic and knowing what is the edge of knowledge, what is that kind of boundary between what we know and what we don't know, and making sure that what the students are working on is actually truly novel, right? And this might be, you might be an expert in that particular area, so you could do that. I was trained as a neuroscientist. So for many years in my life, I knew exactly what was that boundary of knowledge for neuroscience. It's been a number of years now since I've done that kind of work. So if I wanted to develop a cure in neuroscience, I wouldn't feel comfortable on my own knowledge. So I would want to team up with someone who is thinking about these questions on a daily basis, right? We've seen a lot of positive examples, especially for community college faculty who may not have active research labs, of partnering with faculty at more research-intensive institutions who can serve as that expert with the research, but then obviously it's a true partnership because the community college faculty member comes in really knowing the students and what their needs are and making sure to create a course where the scientific research question is novel, but it's meeting the demands for those students. And then you might think, are you really interested in trying to get a publication? What are some things that you could do to try to get a publication, right? Are you interested in producing data that can inform local decision-making? Or are you interested in collecting pilot data for something, right? Sometimes people use cures as a way to try out really risky projects, right? That you would maybe feel uncomfortable giving to a graduate student or a postdoc because you really want them to be able to have a tangible product subsequently. But maybe this opportunity for the cures is to try out something that is high risk, high reward. And if it fails, the students still learn a ton going through that process, but they may not actually need that publication. Although some studies have actually shown that students being co-authors on a publication can be really rewarding for them. Now, I want to highlight that in the ideal world, we have our pedagogical goals and we have our research goals, and students achieve both as part of the cure, right? You're accomplishing your research goals and you're accomplishing your pedagogical goals. But I do want to highlight that you might have tensions that start to emerge between these, right? So if your goal as the instructor is to produce data that leads to publication, and so we've interviewed faculty who teach cures, and a major reason why a lot of faculty choose to teach cures is they see that often it's really hard to balance teaching and research if your position requires you to do both. And cures represent a really really valuable opportunity where you can basically do research in the context of your teaching, and you could potentially essentially double dip, right? And get actually research publications out of what is normally considered part of your teaching load. But I do want to highlight, so while I would say the vast majority of people teaching cures are doing so in a way that they're thinking about their students and what their students are getting out of it. And then in addition, they're like, okay, this would be really cool if we can also get a research publication out of this. But there is the potential, as cures become more popular, for instructors to be like, I need to get research publications out, particularly faculty at R1 institutions or research intensive institutions. And they might say, I'm going to just have my students, I'm going to teach them how to do one thing, and then I'm going to put them on repeat, and they're going to keep doing that one thing. So then they're going to do that one thing really well. I'm going to feel like their data is probably accurate. And that time spent where I could teach students about the conceptual understanding of what they're doing, well, that would be time not spent on them producing data. And so actually, if I want to maximize the data, I can shift my cure that way. Again, I don't think that most instructors of cures are doing that, but this is a potential source of tension, right? That you could imagine a cure that actually shifts in that direction and that students are potentially losing out, right? The same idea that if you're building in a ton of time for conceptual knowledge or process skills, you're giving students a bunch of opportunities to practice doing things that don't actually relate to the research project themselves. That can be really helpful for the students in terms of their own learning, but you may make way less progress with the research. And what we don't know right now, which is an open question, which is a really interesting question to me, is how much research actually needs to be accomplished in the cure for students to get some of the benefits associated with research, right? So I would argue if you shift way too much to the side of research, students are going to lose out. If you shift way too much to the side of pedagogical goals as far as conceptual knowledge or just giving students practice, then they're not going to get some of the benefits of actually engaging in real research. So it's this balance that comes into play. There's also potential tensions between pedagogical goals. If your goal of doing a cure is to engage students in research, but you also want them to analyze data, what do you do when students do an experiment? The experiment doesn't work because of a number of different reasons, and they have no data to analyze. Do you have them go back and repeat the experiment because that's what students in a real research experience, that's what any scientist would have to do? Or do you have them borrow data from another group of students so then they can actually have that process of actually analyzing data? So you have to think about what you privilege here. Do you want to privilege the experience of failure in research, which people have highlighted can be a really important skill for people to learn? But then if you do that, then students may not learn how to analyze data. And analyzing data may be a really important goal that you think the students are going to need to be able to go on and do other research experiences, to be able to go on and do other projects. So there's no right answer here. You as the instructor have to think about, what do you think is more important? Is it more important for them to realize that you do an experiment, if you don't get data, you can't analyze data, you actually have to repeat the experiment? Or do you actually want them to borrow the data from someone else? We've actually shown, we've interviewed some students that have borrowed the data from someone else. And then some of them, really interestingly, actually, when we asked them, well, what would happen in a real research experience in a lab, if your experiment didn't work, they'd be like, oh yeah, I'd borrow data from someone else. And we all obviously know that it's not that easy, right? Like usually there's not another group of students doing the exact same experiment. So we could actually be propagating some misconceptions about what research is, depending on what some of the decisions we make around this. And so again, you as the instructor, you as the department, right, whoever is the one that makes those decisions in your unit, you have to decide what is most important, what is the hierarchy of goals, right? You can't have it all, but there is no right or wrong answer here. And that's where I think it's just so important when you're setting out to try to teach a cure, you really need to start with, what do you want out of this? What are the goals? What are the pedagogical goals? What are the research goals? And then that will help you really make decisions about how to actually create your cure, right? And what do you actually embed into your cure? So moving on, thinking through this backward design approach. So once you've identified your course goals and you've grappled with those challenges of what are your pedagogical goals, what are your research goals, then you want to think about, how do you actually assess those goals, right? How do you actually measure whether students are achieving those goals? Aaron Shortledge and I have written a paper that gives kind of a practical guide for instructors to think about assessment. And in this paper, we organize a list of off-the-shelf assessments that you personally could use to assess your cure that focus on student gain. So existing instruments that measure student experimental design, existing instruments that measure students' interest in something, et cetera. I do really want to highlight that we don't want to get into the habit of just designing your cure and just grabbing an assessment and seeing what pops out in terms of a positive impact. If these assessments don't align with your goals, then don't use them. And it's also really important to realize that even with something like experimental design or data analysis, you can teach a student how to design an experiment in a very specific context. And if one of these assessments actually asks them to design an experiment in a different context, that might actually be a much more complicated process. And so you may, by using that assessment, show that students actually didn't have gains on experimental design. But if you gave them some kind of assignment or some kind of quiz or question that asked them to design experiments specific to your own context and your cure, you may actually be able to see some of those gains, right? So if they don't align with your goals, don't use them, and be thoughtful about how accurate some of these assessments are. I also want to highlight that, surveys can be really great for measuring student attitudes about things, that the surveys are often really bad for measuring students' perceptions of how well they can pipette or how well they can do a particular task, right? And so thinking about the most direct way of measuring some of these things, that is going to be important to think about. Again, we're trying to move away from fishing for cure outcomes to more purposefully designing cures to meet specific outcomes and setting out to measure those outcomes, right? So be thoughtful in terms of the assessment that you're using. I also want to highlight here that this can be a little bit confusing. We can think about assessment in kind of two ways. We can think about assessment in terms of, for you as the instructor, what is the assessment of students, making sure they meet those goals. You can also think about assessment as far as, if you want to create a cure and actually look at the impact of that cure on students and then potentially publish a paper that talks about the curriculum, then that is a different type of assessment, and some of the expectations for validity would be different. I'm happy to answer other questions about that in the Q&A. And then kind of the third piece of this backward design is then once you've assigned the learning goals, once you've thought through the assessments, then you can actually start to design the research and learning activities of the course, right? What aspects of the cure lead to achieving certain goals? Now, the challenge here is that we don't know a lot of this information. We don't know what leads to certain outcomes. We can envision that if your goal is to get students to analyze data, then you probably need to give them opportunities in the course to analyze data to be able to meet that goal, right? But some of these other goals in terms of, increasing student interest in science or increasing student sense of belonging in the kind of science community, we don't actually know at all right now what aspects of a cure lead to these certain goals. And I would argue that we need more backward design studies to look at this to be able to actually identify what features of a cure lead to which outcomes. So that said, I want to transition to kind of the last part of my talk and thinking about how we can actually backward design cures in hopes that you might think about this as a way when you're developing cures, or if you have an idea for a cure, is there a way that you can start to add to the literature on these critical elements of cures and what they actually lead to for students? So then when people 5 years, 10 years from now continue to develop cures, they'll have much more insights into what they actually need to put into their cure. So if we go back to those 5 proposed dimensions of cures that I outlined at the beginning of the talk: scientific practices, collaboration, iteration, discovery, and broader impact and relevance, obviously these are huge categories, right? So, they can be broken down into so many other components, right? When we're thinking about collaboration, are we thinking about group work, right? Are we thinking about the class as a whole working on a project? Or are we thinking about partner pairs working on a particular project? And some cures are set up where the class as a whole works on a project. Some cures are set up where there's groups of students that are all working on their own project, right? And so collaboration may look really different in that. And so you can think about that for each of these dimensions. You can really start to break this down and conceptualize what are kind of critical elements here and what might actually lead to some of the goals in these dimensions being important. And so again, we've started refining this and thinking about discovery, broader relevance is actually one thing as opposed to 2 separate things. And I want you to think about what are studies you could do to predict which of the features of a cure lead to which outcomes. And this is exactly where I was sitting a couple of years ago. And I was like, well, how do we actually look at the impact of some of these factors that these features of a cure that we're saying are so important, how do we actually show that they're actually important? Is there a way that we can set up a study that just looks at one aspect of them? Is there a way to kind of do a reductionist study where we keep everything else the same and we just look at one aspect? And then kind of coincidence always comes into play when you're doing research. I was really lucky that a faculty member of a colleague of mine at Arizona State University, Joe Blattman, was teaching an immunology course. And we had some discussions about cures in general. He knew that I was excited about cures. He was just teaching this upper level immunology course. And he basically had students go through and characterize the immune system of wild type mice. So it went through and did some experiments on B cells, went through and did some experiments on T cells, macrophages, et cetera. And so it was in all essence a cookbook course. Now, it was a cookbook course using some more sophisticated experiments than some cookbook courses. Because of certain biosafety levels, students got experience there, but it was really students followed a series of steps, just like a recipe, just like a cookbook. When he started hearing me talk about cures, he approached me and was like, I think that I can take this course and turn it into a cure by changing one component. And he was like, what if we just swap out the mice so that instead of having wild type mice, we'll work on a mutant strain of mice whose immune system have never been previously characterized. So another faculty colleague of ours at Arizona State University had a specific mouse strain that no one had ever done any experiments on in terms of the immune system. Their immune system had never been characterized, didn't know if the immune system was more activated, less activated, et cetera. And we decided that we could create this into a cure by taking this cookbook course, changing just the one component, literally just switching out from wild type normal mice to these mutant mice, and have everything else in the course the same. The instructors were the same. The assignments in the course were the same. The weekly protocols that students followed, much like a recipe, were actually still all the same. But the difference was, instead of being confirmation experiments where they were following the steps to then compare it to what we already know about wild type mice, no one knew what the results were going to be. The students didn't know, the instructor didn't know, the faculty colleague who had previously studied these mutant mice didn't know, right? So then I was like, this is awesome. This is a perfect opportunity to just look at that discovery broader relevance aspect of a cure and see what the impact could be on students. And so we did this over 3 distinct semesters. The first semester, he taught the cookbook course just in the normal way, and we collected data. And then we collected data from 2 iterations of the cure. Again, everything was the same about these courses. The only difference was in the cookbook course, they were working on wild type normal mice, and in the cures, they were working on this mutant mice. So basically, we were interested in seeing if this course was backward designed to see if students in the cure had more discovery broader relevance, and they should have all the other aspects of the cure should be basically the same. And did they think that they were conducting real research? So this was kind of our proof of concept to make sure that the cure was actually a cure in the students' minds. And so to do this, we used the Laboratory Course Assessment Survey, or the LCAS survey, designed by Lisa Corwin and Aaron Dolan, to measure the extent to which students perceive they experienced collaboration, iteration, and discovery broad relevance. And that was one construct. And then we basically did t-tests to look at any differences comparing the students in the cookbook and the cure. So what did we actually find? So we found no difference in collaboration, which was awesome because students were working in groups in the cookbook. They were working in groups in the cure. Again, we hadn't planned any difference in collaboration. So it was really great that they didn't perceive a difference in collaboration. There was also no difference in iteration, which was also really important because, again, every week they did the exact same protocols in both courses. We didn't purposely change anything about iteration. So that was exciting that we didn't see any difference there between the 2 courses. And then in the construct that we were interested in, this discovery broad relevance, excitingly, we did see differences. We saw that students in the cure did think that they were experiencing more discovery and broad relevance than students in the cookbook course. So again, this isn't necessarily an outcome, but this was just a check to make sure that students were actually feeling like they were doing discovery and broad relevance in the cure. We also, to further kind of establish this, we just asked them we asked them a question with a 1 to 10 Likert scale and then an open-ended kind of rationale to basically ask, do you think that you conducted scientific research in this course, and to explain the reasoning. And again, this was to just further unpack whether they perceived that they were actually working on something that was new discoveries that were broadly impacted. And we found here, just looking at the Likert scale responses, that the students in the CURE were significantly more likely to say that they are conducting real research in the lab course than students in the cookbook course. So again, that's all really positive. And really importantly, when we looked at their open-ended responses, we found that about 56% of students in the CURE talked about their research being either novel or broadly relevant. So this quote says, the research in the CURE was directly relevant to the research being done by the instructor and his lab faculty. The experiments have never been done before. They were done with the intention of discovering something new that can be applied to a broader understanding of immunology. No students in the cookbook course thought that what they were working on was novel and broadly relevant. So that was really good as a proof of concept. Then when we looked at whether they talked explicitly about the research question not being novel or broadly relevant, again, we saw this similar parallel where the students in the cookbook course, 62% of them said, basically, I don't think that this research question, I don't think this was scientific research, because the answers to the questions posed in lab had already been answered many times. Nothing new was discovered, right? No quality material was added to the scientific community, right? So this is all kind of helping us establish that these courses, even though we just changed the mouse, that there seemed like there was a perception of difference in terms of discovery broad relevance. Now, both cookbook students and CURE students recognized that they were able to engage in scientific practices, and this makes sense because both of them were engaging in the exact same scientific practices, right? The exact same immunological assays they were both doing. And interestingly, more of the cookbook students talked about engaging in scientific practices than the CURE students, but this was open-ended responses. They could write whatever they wanted to in that. And so more of the CURE students were writing about novel discoveries. And then this was actually really interesting, and this is something we'd like to follow up on in the future, is CURE students were actually more likely than cookbook students to highlight a lack of autonomy. Neither student had autonomy, right? They were both given lab protocols that they had to follow word by word. And so in terms of a CURE, this CURE had a lot less autonomy than some other CUREs. But way more CURE students highlighted that they felt like they didn't have that autonomy, and they felt like in real research, so they knew they were doing real research, but they also knew that their real research that they were doing was constrained, right? So the student says, it was also different from scientific research because we did not have to decide which experiments to perform, and we did not have to redo failed experiments. So they kind of highlighted that CUREs were mimicking real research, but there were elements of it, because it was a course, because they came in for a set number of hours a week, that was fundamentally different. Okay, so students perceived that what they were doing was discovery broad relevance. They thought that they were doing real research in the CURE, so this was all good. Now we wanted to say, okay, so we backward designed this course. It seemed like that students perceived it as such. What impact did it have on students, right? These courses with only changing the type of mice, did students have different outcomes? And the outcome that we decided to look at was project ownership. So the extent to which students feel like they own their project in some ways. So we used the project ownership survey, which was developed by David Hanauer and Aaron Dolan, and it's composed of two subscales: a cognitive ownership subscale, where they're asked to rate their level of agreement with that they had intellectual ownership over their work, and then an emotional ownership subscale, where they basically ask about how happy or delighted or excited they are about their experience in their lab course. So what did we actually find? So we found that students in the CURE had significantly higher cognitive ownership than students in the cookbook course, which was exciting, that you just change this one thing and we can have higher ownership. We also found higher emotional ownership than students in the cookbook course for students in the CUREs. Now, something that's important, the data that I just showed is looking at averages across the board. We also looked at the distributions of students' data for these things, and there was a spectrum of student viewpoints on this, right? Some students felt like they had more ownership, some students felt like they had less ownership, and even going back to the different features of the CURE, there was a variation in terms of the extent to which students thought that they were engaged in more collaboration, less collaboration, more iteration, less iteration, more discovery relevance, less discovery and relevance. So we wanted to look at, independent of what course the students were involved in, if we just look at all of these students kind of in one giant pool and look at the differences for individual students, could we actually see which features of the course were related to students' cognitive and emotional ownership? So a national study done before this by Lisa Corwin showed that all three course design features, collaboration, discovery, and iteration, are significantly and positively related to students' cognitive ownership, but only collaboration and iteration were significantly and positively related to students' emotional ownership. So this national study basically surveyed from, I can't remember exactly how many CUREs, but a number of different CUREs, and then pooled all the data and looked. So the major difference here is that instead of trying to just change one aspect of the cure, they looked at with this national design at a bunch of cookbook courses and a bunch of cures, and overall what were some of the differences, whereas we just tweaked that one thing and held everything else constant. So we decided we wanted to actually see in our specific cure where we just tweaked the one thing, does Lisa Corwin's results hold up for our cure, or do we get different results? And so we did linear regressions to identify which features of these courses were related to students' cognitive and emotional ownership. And what we found was that collaboration, iteration, and discovery broad relevance were all significantly and positively related to cognitive ownership. And this actually mimics what Lisa Corwin found. So we replicated this with our particular study. So then we looked at emotional ownership, and we wanted to see, again, whether these three features affected it. And in our case, only collaboration and discovery broad relevance affected emotional ownership, which is actually different than what Lisa Corwin's study had found. She found that collaboration and iteration were positively related to students' emotional ownership. So this highlights that, that we need to do more work on this, right? That one study isn't sufficient. Again, that's the only study that's really looked at this, right? Our study is just one study, so we're not saying that this is the end all and be all, but we're saying that more studies need to be done on this to specifically look at this construct of emotional ownership. So in conclusion with this, this reduction study with this kind of really cool design that really happened by coincidence and me chatting with other folks on my campus allowed us to explore the specific impact of changing only discovery broader relevance to understand if this is an essential feature for some of the positive impacts. And it seems like it's important for both cognitive and emotional ownership. And then we've replicated what Lisa Corwin's study found in one component related to cognitive ownership, and we found a little bit different related to emotional ownership. But I think this is a really good example of what you could do in terms of a proof of concept to think about how you could backward design cures and assess them, right? Highlighting that, yes, you need that discovery broader relevance piece if project ownership is an outcome that you're interested in, if project ownership is a goal that you're interested in your students achieving. So I'd like all of you to just leave this talk with this thought, right? Can you think of studies that you could do on your own campuses with your own cures to start to predict which of these features of a cure lead to which outcomes, right? Can you start to unpack different scientific practices, right? I've touched on autonomy can change drastically in a cure. Some cures are set up where students have a ton of autonomy. I would say most cures are set up where students don't have as much autonomy, especially if they're interested in trying to get a publication, because often a novice student doesn't know enough to be able to come up with their own research questions. So you instead give them a prescribed research question, but we have no idea right now whether that sense of autonomy matters or not. I just got done with another study recently where we've looked at, does it matter whether students analyze their own data or analyze someone else's data? And we actually found more positive results when students analyze their own data. So these are all these kind of minute questions that we can begin to kind of tease apart, and they have such profound implications for how we think about actually designing cures. Because right now we're basically in the dark about how we're thinking about designing cures, right? Which is okay, but as we develop more and more cures, if we can start to tease these things out, this would be really beneficial for the cure community. So with that, I'm done talking at you. I just put the titles of some of these papers that I mentioned up here if you're interested in checking them out further. And with that, I will take any questions.
Okay, this has been really good. I have been monitoring the chat during the discussion and trying to drop links of the papers that you're talking about into the chat, and I hope that I've been able to grab them. There's lots of questions, actually. I'm going to try to grab a couple of the questions about your and Dr. Blattman's study to begin with. So there was sort of a question about that, and I hope I know you'll be able to answer this. Is it possible that the results of Joe's study may have also been impacted by the professor's attitude to the cookbook course versus the cure course?
Yeah, that is a really important question. So the instructor made it clear to students when they were in the cure that they were doing real research, and he used language. He was highlighting that what they were working on would be potentially publishable. but so that would be different. His attitude about basically saying in the first version of the course, he was basically saying, you're going to be doing all these really cool immunology techniques, right? And when it became a cure, it was, you're going to be doing all these really cool immunology techniques and you're doing real research and it's potentially publishable. So that is definitely different. Now, in terms of his just general attitude about the course, we didn't videotape the course, so we don't have that. It's really hard to actually be able to assess that type of thing. Based on conversations, we did interview students and we did interview the instructor of the course, Joe Blattman, and we didn't see anything that came out in terms of just difference in enthusiasm. Joe was like super pumped about his course before it was a cure, and then once he realized he could make it a cure, it was almost like he took his excitement about his original course and just had tweaked that element. But we tried to have him not do anything else different in the course to try to keep it as controlled as possible. But I think that who the instructor is absolutely potentially matters, right? And so the benefit of the study that I just presented is we were able to just change one thing in kind of a controlled environment of everything else being the same. But who Joe is matters, right? The specific experiments matters, right? And so the benefit of a study like Lisa Corwin did, is you're looking across a bunch of different instructors at about a bunch of different cures. Now, a critique of that literature is you also could potentially have the problem of maybe instructors that are better instructors, more engaged instructors, more enthusiastic instructors, maybe those are the instructors that are teaching cures and not cookbook labs. So there could be differences in instructor effects there. So these are all open questions that we need to pursue further. Absolutely, the instructor's enthusiasm is going to matter. In that study, we tried to make his enthusiasm about the same.
Yeah, and I don't know if Joe told you, in the middle of the study, I went down because I collaborate with him on something else, and he's like, I got to show you my data. I got to show you my data. Let me talk to you about my cure. Let me talk to you about my cure. So Joe is really an amazing person, and he was really enthusiastic about both. So
Yeah.
that I knew a little bit about that before it ever came out. We have a comment here that I think it would be really good for you to discuss. Someone has said that they would feel more comfortable with this design for lower level courses and non-majors courses. And this, of course, is an upper level majors course, right? So any comments on that?
Yeah, so speaking specifically about the Blattman cure. So I think that, so what I think is implicit in this question is the students are still doing a cookbook experiment, right? In some ways, right? They're still following a very specific series of steps. But I think you can push back on that and say a lot of molecular biology PhD programs, right, are students following a series of steps, right, following protocols that other people have designed. So I don't think that in and of itself, well, clearly it doesn't make it not research. It is for sure research. Now, it takes away student choice, student autonomy. It might take away some of the students' excitement about the projects. So I can't answer that question as far as whether it's better as a lower level course or an upper level course. There's been a lot of push to develop cures in lower level courses because students can experience a cure and then they can use that experience to then leverage it into independent research experiences. That's been one of the big pushes of that. A concern that I have with that push, and that's a push coming from the National Science Foundation and Howard Hughes Medical Institute specifically, a concern I have with that is that that might be disadvantaging transfer students if we're not at the same time really thoughtful about getting cures into community colleges, which I know some of the folks on the call are doing this, and that's awesome. But if we have differences where there's more cures at R1 institutions than community colleges, then I worry that then that's going to just exacerbate some of the gaps for community college transfer students. So I think that there's no reason why we couldn't also have upper level cures for those students. And I actually teach one of those for community college transfer students at ASU in science education at this point. But I think going back to the question is, as far as, you know, this goes back to what are your goals of the course, right? And if you think it's really important for students to have a little bit more autonomy, right, to be able to have more decision making, then this version of a cure is probably not going to be the best version for you.
Okay, great. There were several questions about cures and students at different institutions and the potential time commitment. I know that you have done some blogging, at least, and also I think some research about actually even flipped classrooms and how flipped classrooms can disadvantage students who don't have a ton of time outside of class. And so there were several questions here related to that. So it says the time factor I see being a big issue, especially at the community college. Many students have lots of other obligations and families.
Absolutely. So most cures, not all, but most, I would say, really try to embed the cure into the formal course, right? So I think, Pam, you were talking about earlier, your cure meets once a week for 4 hours, and that's it. That's when the students come in and they do their research. I think it's totally not okay, especially thinking about students with different time commitments, family commitments, et cetera, to ask them to come in, at all hours of the day, like we typically do for students in independent research experience. And that's where some of that authenticity of the research goes away. Because often what happens is, if you're doing some kind of yeast genetics experiment, you might have students put the plate in the incubator and then they don't come in and take the plate out of the incubator. You have a teaching assistant do that, or you do that, or you have the students that come into the class the next day that do that. And so I think that that's such an important point, and I would not advocate for extra time for students in these courses. I think you've got to think about how do you make these courses as efficient as possible? And that's where it takes a little bit of creativity on the instructors, because there's some experiments that you can do in a 4-hour block, right? There's some that it makes sense to maybe have the class meet twice a week for 2 hours each, right? Because you're doing smaller experiments. But yeah, I would not encourage you to ask students to come in after hours, especially if you're at community colleges, if you're at more commuter schools, like that, those are unrealistic expectations.
And I wanted to clarify that in my cure, I wasn't going to make the students come in. I was going to take the plates out, and I said I'd take pictures of them and I'd send them to them. And they're like, no, I'm going to be on campus anyway because I'm taking a picture. I'm sorry, not taking a picture. I'm going to class. And so we had, they would come in for 10 minutes between classes or something like that. So
yeah, and I think
was.
If they can, if they want to do that, I think that's awesome, but just not making that necessarily a requirement. And I think really important for equity purposes, making sure that the students who can put in those extra hours then aren't going to be more privileged, right? And how you write letters of recommendation about them, right? I've actually experienced that before talking to instructors, that they almost have unwritten expectations for what's going to be the best letter of rec. And so I think you want to be explicit. Here are the expectations of the cure, and if students meet those, right, then you should be able to still write them an excellent recommendation. They don't have to be the ones that are coming in after hours.
That's a great point. Yeah, I've got to remember those equity issues because a lot of times I think additionally, in addition to that, students don't want to share that is an issue. And so I, in my privileged state with my biases, think something else, well, they're not that committed. No, they're extremely committed. They just are over committed to everything else. And that's really good to.
Another thing to build onto that is, depending on the cure, some cures are set up where, every student works in parallel, they do the exact same thing. Other cures are set up where students take on ownership of different pieces, especially as a class as a whole works on something. So when I teach science education cures, I often have, often we're developing surveys, and a critical part of survey development is we want to do think aloud interviews with students to make sure that they understand the questions in the survey. And so I ask who is interested and willing to basically do some of those think aloud interviews. And there's some students that are really uncomfortable thinking about, interviewing someone else. So we make it so that it's optional who wants to take on that component, with the idea that then if they don't do that, then they can do another component later on. So we try to make it so that the work is actually equitable, but it's not necessarily equitable every week. It's that in certain weeks, some people might have more or less. And then that could also be really good if they've got a bunch of other stuff happening in their life, then they could purposefully kind of arrange their schedules so they could take on more of that commitment in other weeks that are best for them.
Thank you. There were several questions about the learning outcomes, and several people had indicated that one of their learning outcomes was scientific writing. And they had said, I tried my version of a cure within the ecology course, and I felt the end result of student papers were lacking. What advice do you have on assessment setting milestones throughout the semester? I guess for the scientific writing component.
Yeah, that I think is a really important question and something that I think a lot of us struggle within a cure. So again, I think it goes back to this kind of push and pull between your pedagogical goals, right? So most of the time, if someone's doing a research project in the span of just a single semester or quarter, depending on what you're on, you're not going to write up a scientific research publication based on that, right? And so, so some people have taken the approach of, well, can we ask students to do more authentic assessments? So some cures are set up where students do a poster. And so they write elements, you know, of what they've done on the poster, but it's not as complicated as a scientific research paper. And I think that often is a goal that's more achievable, right? And setting up milestones where, you know, they create a draft of the poster, then they get feedback, then they revise it. Another thing to think about is, you know, if you're really working collaboratively with other people, you know, say you're in a group of 3 people, you wouldn't have all 3 people do separate posters. You would have all 3 people collaborate on the poster, right? We do this when we send students, grad students, postdocs to conferences, right? Everyone who contributed on the project produces one poster that then someone or multiple people present. And so that also might be something to think about is, and again, this is a push and pull, how are you measuring individual contribution and individual kind of intellectual like achievement in the course with what is more authentic in terms of research collaboratively, you know, working on something. I will say for the courses that have moved in the direction of scientific research papers, they've done it so that there's many drafts along the way. They try to break it down so that an introduction is due at a certain point, then they get feedback on that, then the methods is due at a certain point, then the results is due at a certain point. And so it's possible, and I definitely know of cures that have that set up in place. Again, that's a lot of work for the instructor. And so I would encourage you to just think, well, could you do it where if you have partner pairs working on the projects, can they collaboratively write a paper? Is there a way that you feel like you can assess both of their abilities, right, with a paper? Maybe, maybe not, right? And I think that the challenge exists where one person could just dominate and take over, the other person may not. So may not choose to participate or may feel like they don't have the chance to participate because the other person is dominating so much. So I think it's a good question. I would encourage you to, you know, maybe your course has to achieve some kind of writing component, so you have to have scientific writing as part of it. If not, I might encourage you to think about, are there other outcomes that you can get for the students that are potentially less time consuming for you as the instructor grading and also potentially more authentic. Right, you could have them write an abstract, right? And then you could have them do a poster, which is essentially what we would have most undergrads that spend like a summer in our lab do.
Yeah, those are great ideas. I think one person had suggested something they call presenting the data analysis versus writing, like they call them presentation lab reports. So that's a really good idea. So we've got another question in the chat. So we had a lot of people thanking you for your presentation. So we really appreciate it. I really enjoy listening to you. I always learn something. So we've got another question in the chat. Equity is so important. I was one of the students who had no research experience due to full-time work. I learned everything about science as a PhD. I want to give those ops to my students as undergrads. Do you have any other tips for that?
Yeah, I mean, I think that depending on the institution you're at, I think, you know, if you're at a research institution, you run a research lab, we often get to make the decision of who gets to come into our research labs, right? And I think that, as Pam mentioned, we all have our own biases, right? Like a student shows up and they've already done research and they can already talk about research and they've already read my papers, right? Like I'm so inclined to want to give them a research experience. Then the student that shows up and just doesn't know anything, right? But I think we really have to, and I'm totally guilty of this, right? And so I think we have to acknowledge that we have these biases and we have to really think, what do we want students to be able to have, right? And when I try to think through this, I want students to be curious. I don't need them to have read a bunch of my prior papers, but I want them to be curious about questions. I want them to be excited about some of the questions, right? You know, something that I do that I've tried to actually change myself from doing is, so my name often gets misspelled. And if a student misspells my name in like an initial email, I want to just ignore the email because like I'm annoyed that they misspelled my name. But like if you think about it, that's so hypocritical. Like, do we really think that a student is not going to be able to be a good researcher, an undergraduate researcher, if they just can't spell my name right? If that one mistake, right, should dictate whether or not they come. So I think we have to acknowledge our own biases and try to think about more equitable ways of getting folks into our research labs. Again, I think cures are a great way to introduce students to research. Another thing that I didn't mention explicitly is, but I know that some people who teach cures try to do this, building into your cure information about undergraduate research, just in general, right? Helping students in your cure realize, how can you leverage this experience? How do you write about this experience on your CV, right? Because often people think about it, oh, it's a course, like I wouldn't write it about it on my CV. But the reality is they've done research, right? They can use this experience, they can talk about it in grad school interviews, they can talk about it in a job interview, right? It's something that they've thought deeply about for an extended period of time. And so helping them, I think, translate that becomes really important. I'm all about trying to make the invisible rules more explicit to students, to be able to provide opportunities for all students to potentially engage, right?
What about institutional change? We are poised at this moment right now, and there's a lot of discussion about DEI and all of that. Is it time to push changes in bylaws that align with what we talk about?
Absolutely. So I think if we can create institutional change, that's so much. So I immediately went with my previous answer to individually faculty decisions, because I feel like that's often easier, right? It's much harder to mandate institutional change. But yeah, absolutely. If we could change institutions and policies, that would change a lot. And I think sometimes we don't really think about how some institutional policies may actually introduce sources of bias and inequity, unless we really think through some of the downstream effects. So actually something that I've been vocal about at Arizona State University is we have an honors program, which is awesome for our honors students. Our honors students are fantastic students, but as part of our honors program, students have to do undergraduate research as part of that. That's a requirement for the program. And so faculty are very much incentivized to take on honor students. But again, going back to that idea, we only have a certain number of positions to do research in our labs for undergraduates. And so if I'm filling my lab up with all honor students, then where are all the other students going to be able to go, right? If we've mandated this policy that every honor student has to do research, so then faculty are kind of pressured to be able to take those students on, then that leaves fewer positions open for everyone else. And I mean, to push back even further on the honors problem, at least on the Tempe campus, honor students also come with travel awards. They also come with research funding. So there's a lot of incentives in place for me as a faculty member to take on an honor student that comes with all this extra stuff, right, than a student who may not come with this extra stuff. So we have to think about how these policy decisions are potentially changing the demographics of who gets into the lab, right? So I think, Pam, to go back to your point, can there be, so I'm not saying we should get rid of the honors program, but I'm saying, can there be other programs that are developed that are specifically targeting students who are potentially underrepresented, right? Or potentially less academically, prepared, or that are coming in as community college transfers, right? Are we making sure that there's kind of equivalent space available so that one population of students is not taking over all? I think that these are all, I think if we can institutionalize these changes, I think that would be phenomenal, right? I think we also need to move away from a model where a lot of faculty, when they're evaluated based on undergraduate researchers that they're mentoring, it's often just numbers, right? And if I show that I've mentored 25 students, it's like, oh, Sarah's a great mentor. Well, you have no idea if I'm a great mentor looking at 25 students. I might be a fantastic mentor with 5 students, right? And the problem here is it's really hard to be able to actually show that, right? It's really hard to be able to show the value added of an experience, right? And that's where faculty are incentivized to take the very best students. Then you can say, oh, they got into med school because of me, but actually, was that student going to get into med school before you, right? And so I think that these are larger questions that we have to grapple with, but if we can grapple with them, and if we can make policy change, that would be absolutely phenomenal.
I mean, one thing that I've tried to do is whenever I develop the program like the STEM, that it in fact has at least a little bit of an incentive, whatever is in the RFP, that then, the student will come with it, for example, supply money, and we have these things called SUN awards, Sun awards and so forth. And so thinking about, either redesigning an existing program or designing a new program that then incentivize faculty to say, oh, I could take an honor student, or I could take one of these students.
Absolutely. And I run a STEM program for community college transfer students. We get them engaged in research. Many of these students had no idea what research was, right? But we're not using their initial interest in research to get them into the program. We get them in, and then many of them have actually gone on to grad school, but they didn't even know what research was at the very beginning. So that's such an awesome opportunity of a program to be able to completely change the trajectory of students' lives by just giving them more information. And I think, Pam, as you're saying, making sure that they're getting paid for those experiences and that they're not having to volunteer, right? Making sure that faculty are incentivized by something extra that comes along with it.
All right, I think there's been more discussion in the chat. We had some thanks for discussing the equity issue. And then there was, I think, some chat between different people, just more about the paper. If I missed any questions, please type them again, because there's been a lot in the chat. We have about 11 more minutes.
And then one additional thing that I wanted to add. So I'm really involved with the CureNet network. So I think that hopefully the link to CureNet got put in the chat. But essentially, people have developed a bunch of different types of cures, have written them up so you can see all kinds of the different examples, and they've highlighted kind of what are their pedagogical goals and research goals through those. We're also in the process, we're really trying to incentivize folks to write up their cures. And so we're actually doing a fellowship program this summer where folks can get $500 if they're willing to. If you've already developed a cure and you want to write it up, I want to encourage you to do that opportunity. We're trying to grow this database as a resource for folks, but obviously with COVID and life, it all becomes too much. And so it's been hard to get folks to, they develop their cures and then they haven't kind of written them up in the database. But there's a lot of really good information there. There's, there's also a quarterly newsletter that gets sent out. So if you're interested, you should be able to sign up for the newsletter, and that highlights recent papers about cures, different opportunities related to cures. And then I'm happy to share the PowerPoint out with folks. So I'll make sure the organizers have the PowerPoint. So if anyone wants to see all that, you can have a PDF of that.
That would be fantastic. Yeah, we'll put it on the our website afterwards. So I put the link. I think it is it circ.carleton.edu/CureNet? Okay. And then we'd have one more question. How do we apply to the grant? So I think what you're talking about, the CureNet grant.
Yeah, so if you go to the CureNet website, you should be able to figure it out. There should be an announcement there. But I can also, when we're done with this, I can look for the specific URL and send that on to Pam. I don't know the specific URL off the top of my head.
Okay, great. I was in the website, and there's a lot there. I'm not going to be able to find it. Yeah, well,
exactly.
Okay. All right. More questions?
And then I saw, as I was skimming through the comments, someone mentioned ethics training into cures. So there's actually a whole group of folks run by Jeff Olimpo right now at University of Texas, El Paso, that are really interested in developing ethics and responsible conduct of research into cures. And I was part of a group that he led a couple of years ago that highlighted the need for this in cures and how we might think about doing this. So I noticed that comment.
Yeah, sorry, I missed that. I saw that comment and then didn't follow up with that. Yeah, isn't there a paper out about that already?
Yes, there is.
Oh, here we go.
He has an RCN UBE, a larger grant that's focused on folks trying to think about ethics embedded in cures. Okay,
let me get back to that window, and I will drop that paper. I'll drop Jeff's paper right there into. So great. That last link was the ethics paper. And if you're really interested, you should be able to email Dr. Olimpo, right, and just say, hey, I'm interested.
Yeah, because I think the research coordination network grants, they're really intended to build connections among folks. So if you're interested, I'm sure that he would be excited about more folks being involved.
Awesome. Okay. We have, I think, a big question here, maybe to end this with. How do you think that this could work in exclusively online teaching?
Yeah, that's a great question. And a ton of folks have grappled with that over the past year. So basically, the short answer is people can develop cures to be taught online. Obviously, it depends on how you're collecting data. What has happened in a lot of basic science cures is they've shifted the cure to be more data analysis as opposed to collecting data. So they've either used publicly available data sets or they've used data sets that maybe labs had already created. And they've been able to do this mostly, I would say, in a synchronous way. So where all the students come and meet, online via Zoom at a certain time. But there is a bunch of discussion actually starting around asynchronous cures. So I'm really excited. I actually recently got funding along with Melissa Wilson and Caitlin Cooper at ASU. Melissa Wilson is a person who studies, she's a faculty member who studies genetics and thinks about kind of bioinformatics approaches. And so she is committed to actually developing a bioinformatics cure that will be exclusively online, that will be taught asynchronously for our fully online biology degree program. Because we have developed this fully online biology degree program, but the students are not getting research experiences that we know from prior data. That's a problem, right? If we think back to those recommendations that every student should engage in research. And so she's in the process of developing that. We're really excited to see what can be done. We've seen examples of how this can be done, but no one that we know of has done it in a fully online context for fully online students that are a different population of students than our typical in-person students. I also wanted to highlight, so Caitlin Cooper, who's an assistant professor at ASU, she has been teaching science education cures all online because of COVID. And she's also interested in trying to develop more of these for the fully online students. And it essentially has taken the students come in, they have a Zoom meeting, she sends them off on different projects, they go out into breakout groups, and she actually just got done with a course where they went from research question to actually they have a submitted publication with all students as co-authors that they submitted a week after the class ended, where the students actually contributed to the writing. It was kind of insane as far as what she has recently been able to do. And there's actually a write-up recently in ASU Now about it, and I can share that, Pam, with folks. But something that she really wanted as an instructor was to have people have their cameras on with Zoom. And part of the research that they did was they were actually looking at student anxiety online, and cameras being on was a real source of anxiety. And so when they found this, she let the students in the cure turn off their cameras, and the students completed this entire paper with their cameras off, right? Proving her wrong that she didn't need people's cameras to actually be on to be able to do research. It wasn't as satisfying for her as an instructor, but the students actually were still able to fully contribute. So I think, Tess, I think going back to your question, I think that this can absolutely be done. I think you have to think about it in more creative ways sometimes, because you're not going to have the in-person. You have to be super organized, because as soon as I'm sure anyone who's taught online this year realizes as soon as you send people out into breakout groups, it's way harder than having them just break out and then we're calling everyone back together immediately. So you just have to be, I think, more thoughtful and organized. But she basically would have a ton of Google Docs where students would do their work. She would be following all the Google Docs at the same time. That helped her figure out timing and when certain groups were done, and they could come back and ask her questions. And yeah, so it worked really well, at least in the context of that science education cure.
Now I'm muted. We probably have time for one more question about the online. So how would the assessment differ for online versus face-to-face? Can you give any generalities about that, or is it just going to be specific based on the cure?
I think it's going to be specific to your learning goals, right? And what you want students to be able to achieve in the cure. So I don't think the assessments would necessarily need to change. I think what more would need to change are the actual learning activities, right? Because there's some things that would work really well in person that maybe wouldn't work as well online, right? And thinking through asynchronous communication platforms, right? So something that seemed to work really well with students in an online cure was, and I'm not technically kind of equipped with the newest technology, but like Discord and like, right? So not like a typical student discussion board, but they're using various apps to communicate with each other. And that was also really cool to see, again, on the periphery, that students were like texting each other at like 10 o'clock at night about their, like, the cure and what they were, figuring out. And so I think incorporating some of those ways of getting students to actually engage in that asynchronous way. And, what I think is really cool in a lot of cures, different than most courses, is in cures, like the collaboration is real, right? Like you can make it so that it's actually real collaboration. So it's not just that the students are stuck working in a group together, it's that they're bringing in totally different expertise, right? I see a question about the co-authorship of cure work, and I wanted to kind of address this in my final moment because I think that this is actually a really important question. There was a publication a number of years ago in Genetics that had 1,000 student authors on it, and that made the scientific community go crazy. And they were like, how did all those 1,000 students contribute intellectually in the work? And I think that this goes back to larger challenges in our research communities of what constitutes authorship, right? And a lot of journals have specifics as far as what students or what anyone would need to contribute. And I would encourage people developing cures to make sure that the students meet the minimum requirement for authorship, right? And it just depends, right? Like things are really variable. So intellectual contributions can be a single idea, or it can be a ton of like work leading to something, right? And so I think that this is an open question. And I think that, at least for me, I've done cures where students are acknowledged, and that's when they've contributed in some way, but the product is not fundamentally different if they weren't involved. But when I've taught some of these science education cures, I mean, the student ideas are in there. This product wouldn't be the same without some of those students, right? And so that has, to me, necessitated authorship. But I think it's a really important question. Caitlin Cooper, who I mentioned earlier, is also doing some really interesting work lately on the benefits of publications on students. And it seems to be really important for the students to have that tangible product. So I think we have the ethics of should someone be an author or not? And then we also have what is the potential benefit of a student being an author, right? And can that make them actually feel like they are a real scientist and actually really legitimize the work that they're doing at Cure, right? Because I've alluded to this. I think there is sometimes still this challenge where people think that work done as an independent researcher in faculty labs is better than a Cure. We have no evidence for this, right? But especially if they can end up as a co-author on a product out of a Cure, I think that grad schools, med schools, any professional, group are going to look at that and be like, wow, all right, like that's a tangible product that they did it. And then what if they don't care about authorship? That I think actually, and I'm out of time, but I think that that's an important consideration too. Some students don't know what authorship is, right? So I think part of the cure is explaining to them how cool authorship is, right? How important it is, how impactful, what authorship actually means, right? And then it's always up to the student whether they want to be a co-author on the paper, right? So I always highlight that they have to read the draft of the final paper and provide edits on it. They can be minor edits, but they have to read it and they have to approve, the final version. If they didn't approve it, then they would be taken off of the paper, right?
All right, thank you so much. We are out of time. This has been really great. I really, really thank you so much and bearing with us with this very different technology, right? I actually kind of like it better than Zoom. We got this background. I don't look like I'm in the Brady Bunch or something.
Totally. Well, thank you so much for the invitation.
Okay. All right,
and
thank you.
I'm happy to answer questions offline, and hopefully folks can engage with the PowerPoint if they want. So thank you all.